Welcome to this brief R tutorial on vectors. So we're at a point in the course where we've built up some kind of basic wherewithal with the program, and we're now ready to start jumping into ideas that are a little bit more advanced. So in this tutorial we're going to talk about what vectors are and a little bit about why they're useful. So vectors are going to combine information of the same type. And there are just going to be three types that I'm going to talk about briefly. Numeric information is just numbers. Character is going to be strings, so that's things like names. And then logical are going to be true and false values. And so, as I said, vectors combine information of the same type. And the command we're going to use to do that is the C command. I'll show you that in just a minute. And even though this is a new term that we're talking about, vectors are actually going to be really familiar, and they're actually what make up data frames, which are kind of what we've been used to seeing thus far. So vectors are going to be really important for thinking about and carrying out a bunch of R functions, but the reason we're talking about them right now is they're going to be really useful for when we want to look at parts of data sets. So in order to kind of jump in and talk about these topics, let's go ahead and bring up R here. So first let's talk about an example of a numeric vector. So here, if I'm interested in recording something like the weight of my cat over several weeks, I might write down that she is first 4 pounds in a first week, and then 4.2 pounds in the second week, and then say 4.6 pounds in the third week. And because these are all numbers, I can combine them using this C command into a vector. Now if I execute this, I just get the values right back. And if I want to save these values as an object, I can give them a name and then assign using this equals command. And here, if I execute this, I see this x1 pop up, and I see that I've now saved a numeric vector that has 3 elements. So as an example of a character vector, we might want to save information about a bunch of states. So let's say California, Minnesota, Ohio, Iowa, and characters can have whatever length we like. So this vector could have, or this vector has 4 elements, for example. So if we save this and then execute x2, we can see our vector pop back up right here. And then finally, we talked briefly about logical vectors. So let's look at an example of a logical vector. So we can say x3 is equal to true, true, false. So here, when we save and then execute x3, we can see these values pop back up. So you'll notice that each time, the important things are that when I save a vector, the information is all of the same type. So these are all logical values, they're all true and false. These are all strings, which are just characters that are inside these quotation marks, and then these are all numbers. So those are going to be really the 3 types of information that you store. Now, we said before that vectors seem like a new idea, but they're actually what compose the data frames that we've been working with. So as an example, if we bring up the mtcars dataset, and that's small enough for us just to visually examine the dataset here, if we have enough room, you'll notice that this is composed of a bunch of vectors. So MPG, for example, is just a vector of values. Now, this isn't the best example because all of these vectors are of the same type. They're all numeric. So if we look instead at the iris data set, let's just look at the beginning of it, you can see that sepal length is itself a vector of numeric values, as are sepal width, petal length, and petal width, and then species is going to be a character vector. So we've been using this $sign command to refer to specific values, and if I just execute this command right here, if I just ask R to return the species vector, I can see this big vector of character values. And this looks exactly like the vectors that we've been talking about. It's just a bit longer. So here we've got 150 values rather than the 3 or 4 that we've been talking about. So if we wanted to, we could actually save this as its own vector. Let's call it x4 equals. So this is sort of a primer on vectors, which will be really important.